Okay, we've done a lot here over the last few weeks. I thought it'd be a good idea to kind of give a high-level summary and then walk through of what we've built in the last few weeks. So that's what this purpose of this video is. So there's kind of two sections here. One's a review of the functional specification, from an application overview standpoint. What do we need our application to do? Why are we doing this? And data modeling. So we'll look at the data again and what are we predicting and how are we doing it. The second part is a review of the implementation, i.e., what kind of code stack we're using and the services we're using in the Google Cloud Platform. We're going to talk about things like, how we're monitoring our application too, and how we're tracking changes. Some of that will manifest here in this functional specification too when we get to it briefly. All right, so jumping in, kind of a diagram here of our functional specification. We've got this problem where we want to serve clients with predictions from a model, right? So we got these clients. We don't know where they're coming from. We don't know what kind of environment they're using in terms of a device or an OS, right? So kind of in that scenario, an ideal implementation you'd use is a simple web application, right? So that's kind of setting our functional specification. We're going to have clients that interact with a web application to, given their set of data, make predictions to recommend a vacation package, for instance. So we've kind of got four individuals involved, or groups of individuals involved in this process. We've got our clients, which we talked about. We've got our application developers, those front-end developers here in the top left. They're building code to kind of serve this application. We've got our data scientists that are that's down here in the bottom, right? They're developing models and dealing with the data and building those predictive models to that we want the clients to reach, right? And then in the middle, kind of making sure everybody gets their cake, is the back-end engineer and devs. They're allowing the front end to communicate with the model back end to serve the client's predictions. So that's kind of the functional specification that we're dealing with here. So I'm going to hop over to just some of the modeling efforts we worked on. I've got some code over here on the right. We'll push that over for now. First, this data is available on. Sorry, just a second. Let me pull up a link to it and get right back to you. Okay, sorry about that. I decided to pull up the actual data or source of the data that we're dealing with here on the right. It's on Kaggle. It's this holiday prediction package data set. I just downloaded that to my hard drive to work on some models, but you could, if your data was housed in the cloud, you can use the cloud platform to do all this if you want. But kind of the workflow I had was I had a source data that I was working with, so did some EDA on it, right? Found there some missing values, imputed the missing values, tried to one of the variables that's in here is the income, right? And that was that data looks kind of suspicious. The salaries are pretty high here, 20 to 40,000 a month. So units there, or the data that's there looks kind of might be synthetic, but that doesn't matter. We're just need a source data set to make predictions with. That's kind of the goal here, right? And this was just some random data we selected. Anyway, age distributions, typical EDA stuff. Then into the model building, scaling our float data so that it lies between a standard scale, and developing some models. Some kind of key to that is since the data is a bit skewed in terms of true positives, It's a lot of unsuccessful vacation package recommendations that have been made historically. So you got to kind of pick your metric, and we choose recall in this standpoint, or in this particular project, because we're interested in maximizing the ratio of true positives over total positives. So kind of we tried a few models here, and kind of the best performing one, kind of surprisingly, was our logistic regression model. So we wrote a joblib file out into the file system, and we're going to use that in a little bit. I'm going to pause here to get a quick drink. Okay, back and resuming here. So what we're predicting here is the successful recommendation of a package. We have 5 of them that we're going to supply or allow the client to select and see if the model can correctly predict a successful acquisition of that package, basically. So that's the data. Now we will talk about the implementation here. So how are we going to implement the specification, what services we're using, what kind of code are we using, that sort of thing. So as laid out here in this diagram, I chose to implement this in Go as from a web server standpoint. We're going to use Go basically to serve some HTML templates to the user, and I'm kind of mocked up those templates here. Here I've got it in Edge just because I never use Edge, and it's easy to find stuff then. So we've got this client entry data form here that the users will be allowed to input data into and select various booleans here for categorical attributes. We got a verification page in the middle that's gonna, if the user made a mistake here in one of these fields and want to try something again, they can redirect themselves back. Oh yeah, I drew that up. Sorry, let me go back to that. Right, we've got these static pages here that we're gonna allow Go to interact with and put data into them at various locations. We've got kind of the root level. That's the data entry form. We're gonna, when they post that form, right, it's gonna migrate them to the verify page. In that verify page, they'll be asked to verify the data that they've inputted into the form, and if they've made a mistake or want to change something, they can loop back to the home page or choose to get a response from our model. So I'll proceed forward to the kind of response page here. That's kind of the flow. You could likewise do another kind of outer loop here to redirect users back to the beginning, but that isn't implemented in this case. It's kind of a minimally viable product here that we've developed to get this up and going. So as I was mentioning, these templates, data entry form, verify form, that's all basically every field that was on that entry form is manifested here in a table, and then we can submit that to a response, and we're going to get on that response page, we're going to visualize the request that we sent and the response we received from the model. So that's kind of how the data flows within the application. And we can talk about the Go server here themselves. Kind of a key attribute here is, in order to do this, you've got to set up these forms within your HTML templates. So that's kind of, you've got the form here, definition. And we've got our categories here, like monthly income, age, monthly income, passport, the marital status, booleans here, kind of the star rating of the properties we'd want, and the packages that we have to offer our clients. and then there's the submit button, etc. Right. So that's kind of the template form aspect, and on submit up here on the post. Where did I see it here? On the post, it's going to go to verify, right? So verify then. Oh yeah, and also I should mention, these forms have name fields. That's important because in Go, we're going to land that data and request it into the web server by accessing the name field. Sorry, back over to verify. Then, since we're going to have in Go an object that holds all of those values from that form. That's a struct in Go. And that struct is going to have fields. And we're going to access or display the results of that submitted struct or record back onto the verify page by accessing the named fields, right? So 3-star is going to receive the preferred property *3 field within the submission or details struct that was received on the home page. Down at the bottom, or I think this actually put at the top of the page on the verify. Hold on. Yeah, at the top there's either a submit button or an edit data button. We're going to have those as post requests. So when it gets a post to the submit button, i.e. we want to move forward in our application, right? We're going to go forward here to the response page. That's the submit button, right? And likewise, if we want to edit our data, we're going to post that to the root and return back to the home page, basically. So that's kind of the flow in the HTML templates. We can hop over to the Go code here. Several imports, mainly because we've got to access some of the client libraries for the Google Cloud Platform. That's what all these are here, as well as some of the request formatting libraries. That's what this HTTP body library is. And we've got some utility libraries here: print, HTML template, net HTTP, log, reflect, which we're allowing that to come back from an object, and string conversion library. We've got a couple of types that we've implemented. Those are the structs that we're defining to put back data in our form. The submission struct and the result struct. That's again, data received or put into a form. We've got some variables that hold those types or those structs, the details variable, the result variable, as well as some variables that we are going to use to build our request to our Vertex AI endpoint. Quite a few functions. The init function here is basically building our pointer to our templates. So that's, we're going to query the templates directory and get all of the templates that contain a .tmpl extension, file extension. That's what that's doing. And then main is going to basically handle the web server aspect. So when there's a request for home, it's going to run this index function. When there's a request for verify, it's going to run this verifier function. And when there's a request for a response, it's going to run the responder function. And then we're going to spin up our web server on port 8080 there. So that index function basically executes the home template, which is our form, our web form for data entry. Let me just divide this up now so we can run these both at the same time. So that's kind of self-explanatory there. It's just going to load our data form when the request for the root is made. The verifier function is going to get the values from this form. That's what this is, our form value. The fields, we talked about that in the HTML, right? That's the name field in an HTML form. And then it's going to convert that to an integer and then store that in various variables, and dump each variable into the field associated with that variable in our struct. We're going to call that object details. Then we'll, from that record that we've created in the web server, we'll parse that into a request. We're going to parse each field, separate it by commas because that's the format that our Vertex AI API is expecting, and then put it in a string is what we're going to do. And we'll print that to the log so we can have some record in our console on the web server. We build a raw request series by instantiating a pointer, and then we this type here that's built in this library. It's a slice of bytes, and you can use a string, convert a string to a slice of bytes in that manner. That's what that's doing. And the data field within that raw type, raw.data, right? That's the field, is going to be that slice of bytes that's from our query. We're doing that because this client library, to make a request to our endpoint, uses a struct that requires a slice of bytes for a data field. So we built that struct here, and we're going to put it into, this is really complicated, another struct, this raw prediction request that contains an endpoint, the Vertex AI service endpoint where our model is deployed, and the request that you're making to that endpoint. So that's all in building our query, where we're querying and the query that we're making. There's nothing to do with any sort of authentication and of a client yet. That's coming up. I tried initially to do some there's another struct or type within the client library for the Google Cloud Platform. There's a limitation of that actually method or those methods. When you're building the request up, which is what this is doing in the raw standpoint, when you're building that request, the Vertex AI can handle a plethora of different model architectures in terms of, so like say you're using a scikit-learn model, which we're using, right? You can build that model using NumPy arrays, right? So that would have no headers. Or you could build that model using a pandas data frame, which would have headers, right? The problem I encountered when using, not the raw methodology, which would, basically send information directly from this form into the endpoint in terms of the struct, or in the form of the struct, right? There was no middleware within those function methods that allowed you to define what kind of model architecture you were using. So I ran into a lot of problems trying to use this .predict type versus a raw predict type, which I ended up with. But we eventually got it working. So that's why these sections are commented out. So now we built this kind of model request data structure that we're going to, and then that's a pointer, right? Because that's what the client library is expecting. Now we're going to build up our authentication and connection information. So this section is getting our credentials from the user account that's associated with, or not the user account, the service account, sorry, that's associated with where the application is running. So In the Google Cloud platform, right, you can provision service accounts to have access to various APIs. So one thing you'll have to do is, get a service account that has all the permissions associated with the services that you'll need, and then you can request then that service account credentials internally to the application. That way you don't house any kind of secrets or passwords within application code. It's just maintained by the client library itself in the background. So you're getting the client authentication stuff, and then you are establishing a new prediction client with that information and kind of the definition of what you're going to connect to here. If we encounter an error, we're going to log it and into the console and defer the closing of that connection until everything is complete within this loop here. We are then going to we talked about that pointer request kind of definition that's stored in this rex variable here. We're then going to use that context, credentials, and make this request to the endpoint, right? So it's got an endpoint, it's got the information we want to send, and it's applying the credentials to allow us to access that endpoint. Right? That's what this is doing. It's going to return a response and potentially an error. If it does error, we're going to log that fatally, and it'll basically not allow us to display a page here, because that's the end goal here of this function, is to render the, scroll back up, render this verify page. So if this prediction request fails, it's gonna it can't handle the prediction, so why continue to run? That's kind of the strategy there. It's also going to print the response back from the endpoint, just for kind of troubleshooting purposes to the console in the logs. Then we're going to convert that response to a string using the fumped package there, just so we can display it then on the next page. Anyway, once we have that response in terms of a string, right? Since we had this initial data structure here that was a request that was a string and a response, I put that as st, but I could probably name that better. Anyway, we can supply those fields to a variable results here and basically have data to display on our next page. So we put our details into the verify page, made the request to our endpoint on verify, and then on the verify page, right, there's this post here, request, that can allow us to go forward into response, or we could make this post request to go backwards into the home page. If you choose to go forward, it's going to go to response, and then response, when you hit response, run this responder function. What that is basically, if we get there by just typing in an endpoint, i.e. not making a post request, it's going to send you back to home. Otherwise, it's going to take that results struct that we just recorded and verify, and then which is, let's see, verify, right? Take that struct that we've rendered results, and basically render that on the response page in terms of the request we made and the response we got. So that's kind of the code that drives the application. And now we'll get into, I think what I had planned is, services monitoring and track changes. So we'll go through all that here quick. Just a second. Let me clear all this down and get back to here. We can get rid of these guys now. So first thing we should talk about is, and let me get back to our application. All right, so kind of the services we're going to use here, just as kind of an overview. We've got Cloud Build and Run. That's going to handle kind of the automatic deployment from GitHub. Our code is housed on GitHub application, kind of here at this address. It's got some configuration files and our main.go file here. The application all runs off of one single main.go file. There's no middleware or anything else installed. It's pretty simple. Like I said, minimally viable product. We could improve that down the road, but this was kind of just to get this sort of microservice interaction thing figured out. That was the purpose here. So we've got our application up and running on Cloud Run. Its build and execution is automated via Cloud Build. So we've got some associated repository here in Cloud Build that it has a trigger associated to that repository. So it's on push to branch main, redeploy, build and deploy the application, right? On push to main. That's what that's saying. And then so that's everything's up and running. So we've got our kind of web server up and running here. Our client can put in data. I'm just gonna make this guy. We got somebody that makes, I don't know, $30,000 or $30,000 a month. That's pretty crazy, but that's the data set we have. Like I said, they're married and they want, they're cheap. They want to get a 3-star. Well, 3-star accommodation and get a basic package. They're going to submit, right? We'll get a modal to pop up to, hey, your submission was successful. Briefly, before they go to the verify page, it'll display all their attributes that they entered. They can choose to go back and edit if they want. I don't know. I forgot. I'm 49 or whatever, right? No, it didn't store my history. That's fine. I forgot. This guy was married, or this person was married. 3-star basic. Okay, so that was right. Then we can submit that request. It's going to hit our endpoint. It's kind of the request we sent. And the application returned a response of predictions 1. That's true. So that turns out that would be a pretty good package for that person to use. I could prove this application a little bit. Maybe this icon here it'd be nice if that returned us back to kind of the root. But point was to get the application not working, not to make the most robust sort of application in the world. So on the other hand, we can put a client in here. Let's say we're 26. We got our first. No, I'm sorry. We're 22. We got our first really bad internship. We made only $1,000 whatever unit dollars a month. We are single. We want to get the most rockin' vacation package ever. What do you think, guys? And oh no, probably not a good idea. Not going to be successful to market that vacation package to clients with those attributes. So that's kind of the application in terms of implementation. We talked about kind of GitHub integration, redeployment. We can go in here. Let's just do it quick and do something simple like say we want to change one of the color schemes of our template. We can just do that quick. I don't know what this color is. We'll just put 80 in here. Was that 173? I'll set it back when 173. And then we can, you could use Git to do this. You could we have I have this integrated in VS Code. I could have pushed it up from there, but this is a pretty simple edit we're doing here, so we'll just use the kind of stock. So we made some updates to template. What we are going to see now is in the build history. Here Google detected, or the Google Cloud Platform detected, we have a new identifier on our GitHub repository, 2B938EC. Go in here, 2B938EC, that's our commit record on GitHub. It detected that there was a new record, and so it's doing a new build here internally on the Google Cloud Platform. So far, that service hasn't come up yet, and so we haven't had any new logs. This usually takes about 2 minutes to deploy, so maybe we could go here and talk about sort of monitoring of our application. Let's do that while that's running. I built some pretty crude dashboards here to look at the services that we're using here. I've got this global dashboards. We've got sort of the logs, which are pretty handy for accessing errors and reads and or writes or posts and stuff like that from all of our services. That's going in there. Keeping track of our billable instances, that's always important. Things like requests. You can see there's a pretty big gap yesterday where nothing was happening. And prediction count, response count from Vertex AI, and machine utilization on Cloud Run, those type of things, right? So we have kind of a monitoring dashboard built internally to the Google Cloud Platform. So that's what we're, that's how we can see how our application is doing, how many, keep track of our spend too, in terms of our instance count and billable hours, and the data that's being transmitted between the services, requests and predictions made, as well as how our cloud build compute is being leveraged. So, all right, that's complete now. So we can go back to our home page. I'm going to refresh this because this is cached, right? And yeah, we changed our background color there. So this is all working in terms of CD. Right, minimal viable project out the door, serves predictions for clients based on attributes of the clients. Yeah, so that's the demo, guys. I hope you enjoyed it. Hope you enjoyed some description of what we've implemented and this whole project from end to end. So take care.